This is the question which Taha was asking me. Let me read it. The diagram shows a trapezium ABCD. It's a trapezium. This is a trapezium ABCD in which AD and BC are equal. AD and BC, this is AD and this is BC. It is given to us equals to R, and AB is 2R, right? Now, the acute angles of BAD and ABC are both equals to X. These angles he is talking about. Let me use another color. He's talking about these two angles. Circular arcs of radius R with centers A and B meet at point M, which is the midpoint of AB. Now, before we start question, it would be better if we can draw these lines, because I'm sure he's going to talk about the area of a trapezium. So it's better to drop the height from D to AB line and also from C to AB line. So we do this. Now, this looks like a right angled triangle. So in a right angled triangle, we all know if we know the hypotenuse, we can easily find the opposite, which is R sine theta, and the adjacent should be R cosine theta. The same thing here, R sine theta in the other triangle, and the adjacent is R cosine theta. So from here to here, we found it. From here to here, we also found it. Now the total is equals to 2R. So what it should be, guys, so it should be from 2R, we need to subtract R cosine theta, R cosine theta. In total, it would be 2R cosine theta that has to be subtracted to get DC. Clear? Now, if I want to find the area of this trapezium, so it would be half times the sum of the parallel sides. The first side AB is 2R, and the DC side is 2R minus 2R cosine theta. Clear? 2R is my AB side, and 2R minus 2R cosine theta is my DC side, times height, and the height is R sine of theta. So this A represents the area of a trapezium. Area of trapezium. Now let's read the question. Given the sum of the areas of the shaded sectors is 90% the area of a trapezium. Now, which shaded sectors? You can see ADM and BMC, they are the shaded sectors. We all know what is the formula for the area of a sector. So area of a sector is, I'm calling this area as A1, the sector. And this is my second congruent sector A2. So A1 should be equals to half times radius squares times x. Clear? And the A2 should be the same, half times radius squared times x. Just one thing is to be taken into consideration, that this angle is not theta, it is x. Clear? So let's write the statement which is given to us. He said that A1 plus A2 is 90% or 0.9 times A, which is the area of a trapezium. So let me copy the formulas which we have come up with half times r square x plus half times r square x, 0.9 area of a trapezium. We found it. Let me copy it here. No need to put the brackets. Half times 2r plus 2r. Why not? I can write 2r plus 2r as 4r. So 4r minus 2r cosine of x, and then multiplied with r sine of x. Now in this expression, it would be easier for me to cancel half, half, and half. Also, r square is in this term and r square is in this term. And why not we can take this r common outside. When I take it outside, it will also becomes r square. So it would be better to cancel r's also. Clear? Now what is left to me? X plus x is 2x on the left hand side and then 0.9. Also you guys can take 2 common. So what is left inside? 2 minus cosine of x and then sine of x. Now this 2 is also cancelled with this 2. Now what is left to me? X is equals to 0.9, 2 minus cosine of x and sine of x. Is this the thing I want to get? The answer is yes. We got the same result which was required by the examiner. So in all questions related to numerical solutions, sometimes the examiner try to model the equation through different concepts taught in AS or A2. And it is most likely the examiner will pick the circular measure questions, which will help you to use the formulas of circular measures, area of a sector, arc length, to establish any equation. After making this equation, he's gonna find the roots of this equation. So in numerical solutions, the first thing is whenever an equation comes in front of you, you guys have to verify that the root lies between the two fixed values. In other words, if you try to draw this function, yani y is equal to x line, everyone knows that this is y is equal to x line. And if you try to draw the graph of this, suppose this is the graph, I'm just drawing the part of the graph. So you guys can see the intersection of y is equals to x and y is equals to 0.92 minus cosine of x sine of x is happening at this point. So this point, we want to make sure that it is between 0.5 and 0.7. Got it? Now, how can I confirm that this intersection is happening between 0.5 and 0.7? So, my dear friends, you can see on the left hand side what is happening. Our blue curve is up and our red line y is equal to x is down. Whereas on the right hand side of the root, you see a difference now. Y is equals to x is coming up as upward curve and the blue curve is looking like a downward curve. So the nature of the curves, that which one is giving higher outputs than the other graphs output, changes at the point of intersection. So what you need to do in the exam, you just need to substitute zero point 0.5, substitute zero point 0.5 into the equation which you have driven. X is equals to 0.92 minus cosine of x and sine of x. At first, you have to convert your calculator in a radian mod. Okay. Now I'm going to substitute on the left and on the right and try to compare their values. So x is coming here. When I substitute it, it gives to me 0.5. Now I'm going to substitute x also on the right hand side to check the numerical answer. Is it positive or negative? So cosine of 0.5, bracket close, close, and then I put sine of 0.5. So guys, what is the answer I'm getting? I'm getting 0.484. So which one is bigger? Your 0.45 is bigger. So this is an upper curve and this should be a downward curve. Around, and if you substitute x is equals to 0.5. Now let me substitute the second ending point, which is 0.7. So x is equals to 0.7 I'm substituting. Let us substitute 0.7 instead of 0.5. What the answer comes to me, 0.716 approximately. 0.716. Did you take notice of this? In this situation, the right hand side is bigger than the left hand side. It tells me that the right hand side equation graph is upward and the left hand side graph is downward. When this happens, it is for sure as per change sign rule, as per change sign rule, there is a root of this equation lies between 0.5 and 0.7. And Taha, we can use another way. Yani maybe in the answering scheme, you will find a second technique. Second technique is this. People bring everything on the left hand side. Yani I was having x is equals to 0.92 minus cosine of x sine of x, rather than changing the left and right hand side numerical answers and their comparison. You can send the right hand side to the left. I'm going to write here x minus 0.92 minus cosine of x and sine of x. Now basically you are going to get an equation which has left hand side is f of x. I'm trying to find the value of f of x for two inputs. I'll try to find f of 0.5 and I will also try to find f of 0.7. Now when you will substitute in the place of x 0.5, you will be getting obviously um, a positive answer, a positive answer. And when you substitute 0.7 in the place of x, this f of 0.7 will be negative. That's why I said this is a second technique where we can use the change the sign rule. Okay? So change sign rule method ensures that the root lies between the two equations. Third question, show that if sequence of values from 0 to pi by 2 given by this iterative formula converges, then it converges to the root. As you all remember, in Numerical Solutions chapter, the second concept which you took, any equation, we can find its approximated root rather than exact root. In the previous part, you did not find the root, but you found that the root, if it exists, it lies between zero point 0.5 to 0.7, and this is 100% surety. So you did not find a root, but you said the root is between the two values. But in the C part, you are trying to explain that the root which you will find for this equation or for this iterative formula will give you the same answer which the original equation is giving it to you. So which equation we have it? Let me copy it here again so that I can focus on making this equation. So I'm trying now to convert this equation into this form. So the root lies or converges to alpha supposedly. And I'm saying my answer is my root is alpha. So let x is equals to a or alpha, whatever, is a root of this equation. So for sure, the iteration is going to converge towards a. So I'm going to substitute in the place of x a. So a is equals to shift cosine and 2 minus x over 0.9 sin of x. In the place of x, substitute a, because a is the root of this equation. Can we transform this equation into this form? Then I can say, yes, this formula, is actually converging to the root of the original equation which we drove in the first part. So let me try to simplify it, or trying to convert into that form which is the first equation form. So send the shift cosine to left, so it turns into cosine of a is equals to 2 minus a over 0.9 sine of a. Clear? Keep your focus on the equation which we want to make. Why not? We can switch the places of right and left. So I'm going to write a over 0.9 sine of a to the left, and on the right side cosine a will be shifted. Now I'm allowed to do the cross multiplication and send it to the other side. Be careful, we have two terms. You need to put the brackets on the right hand side. The final result comes to me 0.9, I will write it on the left. So 2 minus cosine of A and sine of A. Imagine, guys, this equation which we got for the particular value of A is satisfying this equation. So if x is equals to A is the root of this equation, you will definitely get this equation. So hence x is equals to A, or at x is equals to A, this formula, this iterative formula converges to the equation in part A, which we drove. Final thing, the third step of numerical solutions chapter, which I have taught you, you have to find now the approximated value of this A. But how many decimal places are needed? Two decimal places. Got it? Now, every result, you have to write it to the four decimal places. Got it? To the four decimal places. So let me write this iterative formula again. X raised to power n over, and x in the subscript, I'm going to write n plus 1 equals shift cosine 2 minus a over 0.9 sine of x raised xn. Yes. To get the sequence of iterations, we need to give a starter. Starter can be, don't you remember, we said that the root lies between 0.5 and 0.7. So you may assume your first value, which from where you want to start to get the next iteration. So I'm using x0, x1 is equal to 0.5. So I'm going to look for my x2. So x2 will be shift cosine 2 minus 0.5 over 0.9 sine of 0.5. Did you see, guys? Here I'm going to substitute my starter, which is 0.5. Now, on the calculator screen, you can see I'm writing. Make sure your calculator is in a radian mode. Shift cosine 2 minus fraction 0.5 over 0.9 sine of 0.5, close the bracket, and then finally close the bracket for the angle of shift cosine. So get your answer, 0.5712. So we have to write every iteration to the four decimal place, 0.5713. 0.5713. So to the four decimal places, we approximated. Now I want to get x3 by using x2. How the formula looks like? Shift cosine 2 minus x2 over 0.9 sine of x2 to get my x3. No need to write 0.57. Your calculator has already taken that value. So that is saved as your answer. So what I'm going to do, guys, I'm gonna replace 0.5 with ans, and on the top in the numerator I'm gonna again replace 0.5 with ans. Ready? So press the equal sign to get your x3. So x3 comes to me 0.5987. 0.5987 to the four decimal places. Right? Now automatically, now if you press the equal sign, calculator will pick the answer of the display. I'm ready to get my x4, yani fourth iteration. So it give me 0.6100. Get your fifth iteration, 0.6149. All the values of your upcoming iteration has to be in four decimal places. So next, x6, 0.6169, x7, 0.6178. Shall we go to the eighth iteration, 0.6182, and 0.6184. 10th iteration, 0.6184. Now, where to stop the iterations? You have to know that you want to write your root exactly to the two decimal places. So keep your focus on the first two decimal places. As long as they are not repeating, your iteration will not stop. Okay, your first value came, your x2 comes to you 0.5713, and then 0.5987. You can check that 0.5 starts repeating. Okay, after that we see 0.6100, 0.6149, 0.6169, 0.6179, and 0.618. I think you guys can stop at ninth iteration. The reason is the third decimal starts repeating. So hence the final answer which comes to us now, correct to the two decimal places, should be 0.62. Why? Because our answer came 0.6184 in the ninth iteration. Where did we stop? Okay. So we need to round it off. So after 1, what is this? 8. So we need to stop at 0.61, but round it off. So this 1 will becomes 2. So that's why my answer is A is equal to 0.62.